session 3 of Fundamentals of Additive Manufacturing Technology. So today we'll be discussing on some questions of school path planning. Um, so let's start with the session. And uh, regarding the questions and doubts asked in the last live session lecture, uh, those questions, all those questions, assignment questions like question 8, 10, 7, 11, 16 were solved in the Friday session. So if anyone has any particular the doubt, please refer to that video because those answers, those assignment solutions, assignment 2 questions have been solved elaborately in that lecture. Okay, coming to this lecture. So today we'll be discussing on the area filling methods and contour parts, area filling methods, and a brief introduction to liquid additive manufacturing. And we will also be looking into various types of area filling and area filling methods and tool paths. This will be our focus. So let's start with the session. Okay, I'll be very glad if all of you answer these questions. Which of the following are area filling paths? Grid cutting, pixels, mask, all of the above. Okay, so area filling path consists of four methods. Grid cutting, pixels, path, mask. Okay, so correct option is all of the above. Now I'll briefly explain what is the significance of each method. Grid grid is grid cutting is for removing the unwanted part. We'll be discussing on this completely now. Pixels is material cutting or addition is governed by resolution of pixels. Path, again we'll be discussing elaborately. This consists of various paths. Raster, zigzag, contour, spiral, space filling, and hybrid. Also there is continuous. And the last one is mask. This is negative of the material region in a slice. Okay. So these are the four methods. Now moving on to the next question, where this is a connection of the following previous question. the grid. What is the grid cutting method? Which of the following includes grid cutting method? So as I discussed earlier, grid cutting, this is mask, this is pixels, this is grid cutting. Now we'll elaborate to understand the grid cutting. This is a very important phenomena. Now, as we know, area filling methods, we'll discuss on this topic. So there are basically two main methods to convert 3D model into control data of the additive manufacturing machine. That is two main methods, two main steps to convert 3D model into control data of additive manufacturing machine. That is, one is slicing and another is tool path planning. Now, slicing we had earlier already discussed in the previous class. It was in the previous lectures part. So today we'll be discussing on the tool path planning. Now there are three different types of tool path. There are three different types of toolpath. Corresponding to the scanning of outer contour, scanning of inner contour, and scanning of inside area. Now this inside area scanning is also known as area filling. So suppose this is an outer boundary of a object which we want to scan, and now our aim, now here we don't want any material, no material, okay. So this is the inner boundary. This is the inner boundary. So our question is, how can we this shaded area, how to add material in this zone? To do this, we will follow the grid cutting method. The answer to this question lies that we have to follow the grid cutting method for this. Now, the method of adding the material in the required zone is called as area filling method. Like I'll show you, this was the outer boundary, this was the inner boundary. This entire region will be done by area filling path. Now this outer contour is the collection of line. Now, as earlier said, this area filling method is done by four methods: grid cutting, pixels, mask and path. Now, suppose let us take an example of a method such as laminated object manufacture. Okay, so in this method, what happens? Raw materials are in form of sheets. Please understand all this because it's a very conceptual. Now here raw materials are joined together in with the help of thermal or pressure activated glue. This is the mechanism of LOL. Now cutting operation is performed to separate the unwanted part. Now, area filling is not required to fill the inside area. However, it is required to remove the unnecessary material. Okay. So as we know, here the raw material is in the form of paper sheets. As the sheet is joined with another sheet of bottom side, we need to separate out the unwanted region. Now if we cut the path along with the contour obtained to the like I'll explain. This was the inner region which we do not want. Okay. Now if we need to separate out the unwanted this region, if we cut the path along with the contour obtained to the side slicing, this region where material is will also be separated out. Okay, so what will happen is this region with material will also be separated out. So how to remove the unwanted this portion after completion of the part. Now for this, grid cutting is performed. And now what is grid cutting? It is like as we have seen in the lectures, it is a combination of X and Y passes. Now these passes are associated with cutting operations such as laser and knife. After completion of grids, user can easily remove the grids laser on so that we get the outer periphery corresponding to the desired objects. Now, if we do not provide grid cutting, if we do not provide grid cutting, it will be difficult to obtain the specific part out from the object we produce. So this is the mechanism of grid cutting. And with this, we have understood how and what is the grid cutting, and uh, such a similar concept of question has also been asked in the assignment, for which I think you will be getting the answer very easily. Grid cutting method for LOM to remove unwanted material is applied on. So as per the explanation, if you follow, you will be easily getting the answer. Okay, so let's move on to the next question. And with this, I also want to explain that I'll just write one more. Okay, okay. This is the correct option for this question. Sorry. So basically, you need to understand that grid cutting. In grid cutting, we can get the outer periphery corresponding to the desired objects. Like there will be an outer boundary, there will be an inner boundary, and we need to obtain the part between the outer boundary and the inner boundary. So in this method, grid cutting will be used. And in LOM, you will be as the sheet is joined with another sheet of bottom side, we need to separate out the unwanted region. And if we cut the path along with the contour obtained through the slicing, then the region where the material is also present, like here, it will be also be separated out. So in this type of thing, you need to follow grid cutting. If someone wants to refer the first question, which is also similar, which of the following are area filling paths? Answer is all of them, because all three of them are area filling paths. Okay, so if there is no more doubts, we can move on to the further question. Just I'll write a line about LOM. Here, cutting operation is performed to separate the unwanted part area filling is not required fill the inside area however it is required to remove the unnecessary material. Now moving on to the next question where we'll be discussing on the area filling path. So, okay, which area filling path is advantageous? Out of like we have different area filling paths as we already discussed here. Raster, zigzag, contour, zigzag and contour, continuous, hybrid. So out of this, which is better? Okay. So, can you just explain? Okay, I'll proceed with the explanation part. So, area filling tool path, we'll understand. Like, I'll just go starting by explaining what is raster and everything. Yeah, B is the correct answer. Now, this time we do not have many numericals, so we'll be sticking with theory. Okay, so let's start with raster. Now, this is a simple, efficient, and robust, and this pattern can be followed with any boundary. Efficient and robust. With any boundary. Now, okay. Yeah. Okay, yeah. Yeah, yeah. Please proceed. Yes. It is correct. So, yeah, I'll move on with explanation for each of the parts little bit. So, raster we have like it is we have X raster scanning, Y raster scanning, and Y raster scanning. I'll just draw the images for all. This is X raster. This is Y raster, and this is XY raster. X raster, Y raster, and XY raster. So now in X raster, suppose let's point this is 1, point this is 2. So tool is moving from 1 to 2, and at 2 it gets switched off. Then it tool is lifted in air. Then it moves to 3 like this. This dotted line is when it is lifted to air and it moves to 3, and at then it again deposits from 3 to 4. This is the so dotted lines are movement of the tool in air. Dotted lines are movement of the tool in air. So now what happens in X raster? suppose the strength along this sigma 1 and the strength along this is different, sigma 2. Same happens with y raster. Now here in y raster, we deposit the material along y direction. So let's take this as 1, name it this as 2, and tool moves from 1 to 2, and then it is lifted in air, it moves till 3, it moves till 3, then again it starts depositing, and from 3 to 4 it deposits, and the same pattern is followed. So now here the material deposition is along y direction, and here also the sigma 1 and sigma 2 are quite different. Now what happens in XY after scanning is tool moves along in x and y direction. This is done. Now here this is done to get the homogeneity in the deposited material. XY raster, this is done to get the homogeneity in the deposited material property. Now, when we are adding the material in x-axis, the strength of the part in x-axis will be different as compared to y-axis. This was for x raster scanning. But now in xy raster, the strength will be quite similar in both directions. That is in xy and x2 and x direction and y direction. So this is a combination of two rasters scanning. Now next let's move on to the next scanning, which is the zigzag. Next tool path, zigzag tool path. Now this is the most commonly used tool path in additive manufacturing. This has less build time and fewer transition motions. So what happens here is tool, let's go, tool moves from here to here, then it goes along the path, then again it comes to here, it deposits material here also. This will be the path followed. 1, let's name this is, again it comes here, so like, so here in the end tool doesn't lift, in these portions tool doesn't lift, in the end tool does not lift like the raster tool path. It keeps on adding material and reaches to the next line. While this is the difference, in zigzag path the tool does not lift and it keeps on adding material and reaches to the next line, while in the raster path the tool lifted, it was in the air from 2 to 3 and it did not add material. Okay, so now the boundaries of the contours are approximated to linear edge. However, due to the discretization errors on any edge which is not parallel to the tool motion direction, like these boundaries. I'll just write it. Boundaries of the contour are approximated by linear edge. So this is the disadvantage of zigzag path. So that is why, as we will see after contour path, why we use the combination of contour and zigzag path. So there are some discretization errors. Discretization errors on any edge which is not parallel to the tool motion direction. The outline is poor. So here, when the tool is deposited on the edges, it is not necessary that it is parallel to the tool motion direction. So what happens is this outline is not poor. The outline is poor. This leads to poor surface quality of the printed part. And the zigzag path is also called as direction tool path. Direction parallel tool path. Now, next is contour path. So, till now we have discussed the raster path and the zigzag path. Now, contour path is applied by offsetting the contour of the geometry. Like, it's difficult to draw the diagram, so I'll just, for better reference, I will M02 L04, if you can refer there, you will see in the lecture notes given, you will see the contour path which is uh, which uh, which is a series of offsets that start at the outer boundary and progress towards the center. But here the disadvantage is again that we can fill few lines from outer by using contour. The outer profile will not remain as good as it is required. Like for raster path, it approximates any contour by linear edges. Again, the contour path, it will create a series of offsets starting at the outer boundary and progressing towards the center. So that is why in the end we prefer a combination of zigzag and, I'll just write one more line. Series of offsets starting at the outer boundary and progressing towards the center, and is also called as contour parallel or model offset. Now, zigzag plus contour path. This is also known as hybrid path. Combination of different approaches for advanced benefits. Now here we fill few lines from outer by contour path. Parallel and from inside we can use zigzag. Now zigzag. Now why like contour? Contour parallel from inside. Use of spacing. Why we do not use contour inside? Because contour parallel from inside will leave cavities. So a combination of zigzag and contour path gives the best option. Yes. Okay, 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 okay. Okay, it's like yeah, we can discuss, but it's like that key that we need to follow some specific instructions that we need to whatever questions we are doing that should be done very elaborately because maybe all are not aware of the things. But still, yeah, I'll follow that. Okay. So, and also one more thing, this when then the hybrid path scanning is done in X direction or at an angle of 45 degree. So what happens is when you do in X direction on an angle 45 degree, we use the combination like first layer scanning at 0 degree, the next layer at 45 degree, the next layer at 90 degree. Like this, if we do it, then the final part will be quite homogeneous. Okay, this is a very important part. Scanning at 45 degree. Scanning at 45 degrees. Like each layer scanning should be, if we do each layer scanning to be different, like at 0, 45, 90, so on, the final part will be homogeneous. Okay, so moving on to the next question. This next is what is the mechanism of galvanometer? Okay, so as we know, the liquid additive manufacturing, the liquid form of raw material, it consists of two methods, polymerization and liquid aim. Polymerization and rapid freezing. Now, polymerization method, we know it uses UV light. The UV light falls onto a photocurable resin and it starts hardening. And after some time, it forms a solid body which can be used as a prototype. So, what is the arrangement of galvanometer? Arrangement of two mirrors orthogonal to each other. These laser beams, like so one laser beam comes and strikes a mirror, it gets deflected and it again strikes another mirror and falls down. So, this is the mechanism of galvanometer. So, what is the like why we use these galvanometers in additive photopolymerization process? This is because the mass of the mirrors are very less, and hence, if we want to deflect mirrors at very high speed, then these laser beams can move with very high speed. So basically, the main use of galvanometers is mass of the mirrors are very less, and hence if we want to deflect mirrors very high speed, and we can deflect mirrors with high speed. Laser beams can move with very high speed. So inertia of mirrors, the galvanometer is used. So because the mass of the mirrors are very less. So moving on to the next question. Which raster? Okay. No, I was just explaining like why is galvanometer used in liquid additive manufacturing process polymerization. Yes. But the main objective of using galvanometers is because here the mass of the mirrors are very less, and because of that we can deflect mirrors at very high speed. And when we deflect the mirrors high speed, the laser beams can move with very high speed. And as the laser beams move very high speed, they strike the mirror, get deflected, and again strike the mirror and again get deflected, because as we know we strike them, there are two mirrors which are arranged orthogonally to each other. Okay, so moving on to the next question. Since some of you requested not to write, so I didn't write, but still I think this point is important. Okay, so moving on to the next question. I'm sorry, this font is quite low. Yes. This we already discussed. I'm sorry that there's some not able to change it. Okay, so this much is from my side. If you further some people have any further questions, you can put it forward. And for like your reference, the questions or assignment questions of the week two, those have been discussed. So you can please refer the week two problem solving session videos. Yes, this is the question for week three, and in week three mostly you have this tool path and liquid based additive manufacturing questions. And okay, I want to put one more question. I haven't prepared the slide for that, but still I'll just put for the question. Okay, this is on the question on the like there is a miss in when you generate a STL file, there are some missing triangles. So like how do we regenerate those missing triangles? I want to discuss that. So the missing triangles in an STL file, those can be regenerated. There are various operations like transform, repair, shell, rotate, translate. But so from that, when we there are option comes a repair. From this with that repair, we can generate the missing triangles. This is one more question. Some other questions are on based on the softwares Ultimaker Cura or the whichever slicing softwares you would be using. Basing on that, you have various questions on your assignment questions. One question will be given that for a given STL file, the supporting overhang angle in the is the angle of inclination of the triangle normal from which direction? So you have to just put, this is a very basic question, you have to just if any one of you is familiar with how 3D printing technology or have you ever printed, then you just can think that this will always be normal from the build direction. Yes.